Right now. Okay. Today we're just going to be reviewing some qualities of polygons and quadrilaterals. So we're taking this from section 8.5 polygons and 8.7 quadrilaterals. So first thing we'll do is talk about some, I guess, characteristics of polygons. So the first thing is that it has to be a closed plane. Second thing is that it has to have 3 or more line segments. Then the sides meet but do not cross. Of a polygon, I'm going to go ahead and draw one with 5 sides. Notice that it all has these straight lines. Here's an example of a polygon. It's closed, there are no openings. It has 3 or more line segments. And then the lines meet, but they don't cross over each other. For example, this would not be a polygon because it's crossing at this point. And here though, we have these points where they do meet. And a single one we call it a vertex. But when you want to address more than one, we call those vertices. Remember the triangles we called each side a leg? Well, on a polygon, or any other shape, we just simplify it. So we're going to use some of the different polygons, and the polygons we name it depending on the number. And depending on the number of sides, we're going to have a different one. This completely review. Everyone should know this already. So if we said that a polygon has to have 3 or more sides, obviously we're going to start with 3, and we all know that as the triangle. And then 4, if it has 4 sides, we call that a quadrilateral. If you have 5 sides, it's considered a pentagon. 6 is a hexagon. 7, heptagon. If it has 8 sides, we call it an octagon. 9 sides, nonagon. 10, decagon. And then you could go on forever and ever, but it gets easier because if you have an n number of sides, you just call it n-gon. For example, if you have 27 sides, you just call it a 27-gon. That's easy. Okay, moving on. You need to also remember the word what a regular polygon is. A regular polygon is a polygon where it has all congruent sides and angles. We saw an example. Oops, sorry. All the sides are congruent and all the angles are congruent. We call it an equilateral triangle. And how about for a quadrilateral that has equal sides, equal angles? it's a square. We're talking about quadrilaterals. Let's go in and review some of the different quadrilaterals that we know about. So go ahead and label your paper as quadrilaterals. We will go ahead and name them, and then we're going to draw one, and then we'll name some of the characteristics. So the first one is called a parallelogram. Remember yesterday we talked about parallel lines being that they can go on, and they so a parallelogram looks something like this. So notice some unique things about this parallelogram is that I have a side here and a side here that's parallel. So these two lines, let me show you these pens. This one and this one, I place it on the edges. It can go on and on and on, and it's not going to meet. So we have parallel sides there. Also though, notice that it has these other sides where these lines, if I continue to extend them, can go on and on and on, and they will not meet. Hence the name parallelogram, because it has lots of parallel sides. But not only that, but this parallelogram is interesting because this side up here is congruent with this side down here. They have the same length. And this side right here is congruent with this side right here. But wait, it has more. Not only are the sides congruent to the opposite sides, but also the angles are congruent. So let me draw in some angles here. And that's congruent with this angle right here. And this angle here is congruent with this angle here. Sorry if it's hard to see. I just put tick marks in the angle markings to show that those angles are congruent. So we'll leave it at that. A rectangle then is our next step. We have a rectangle. We'll draw a rectangle. We know what rectangles look like. Now rectangles are very similar to parallelograms and carries a lot of the same characteristics. So first thing that you're going to notice is that yes, they do have opposite parallel sides. Not only that, but just like a parallelogram, you're also seeing that, hey, this side is congruent with this side, and this side is congruent with this side. But something a little bit more unique than the parallelogram, whereas the parallelogram had this angle and this angle congruent, and then this angle congruent. Well, a rectangle has 4 congruent angles, and they are all right angles. So I'm going to put the right angle sign that we had learned in class. Next we have the rhombus. Rhombus basically looks like a parallelogram, except you're going to draw that. So you'll notice that again, just like the parallelogram, it has this side that's parallel, these two sides. It has these two sides that are parallel. But unlike the rectangle and parallelogram, all 4 sides are equal length. So this is congruent with this, which is congruent with this length, which is congruent with this length. So all 4 sides have the same measurement. But it does share the same characteristic as a parallelogram because the opposite angles are congruent. And this angle. Oh, sorry, it's kind of blurry. Okay, we just have 2 more to go. I'm going to flip to another page. The next one is a square. We know what a square is. Square. The square looks like this. We're going to again see similar characteristics from a parallelogram where this side is parallel to this side, and this side are parallel. And then just like the rhombus, this side is congruent with this side, the length of this side, and this side. So all four lengths will be the same. And then just like the rectangle, for the square, not only are the sides the same, but also the angles are all right angles. It's almost like as if you put a rectangle put together with a rhombus, you combine their features, you get a square. Okay, the last quadrilateral that we need to cover is the trapezoid. Trapezoid looks like this. The trapezoid does not have two pairs of parallel sides like we've been seeing with the parallelograms and the other quadrilaterals. It only has exactly one. And we remember when we did some of those formulas for areas, we found out that we call these the bases. The sides that are parallel are called the bases. These two lines are not congruent, nor are they parallel, and then none of the angles necessarily have to be congruent either for a trapezoid. A trapezoid is simply, in order for something to be a trapezoid, it simply just has to have exactly one set of parallel sides. Yesterday we said, in your notes, you took that, well, no matter what type of triangle you had, if you add up all the angles, it's going to come out to 180. In this case, for quadrilaterals, the sum of all angles in a quadrilateral are going to equal, 360 degrees. So no matter what type of quadrilateral it is, whether it's a parallelogram, a square, trapezoid, if I add together all their angle measurements, it's always going to come out to be 360. So let's use that as an example, and we'll be doing a lot more class exercises on this in class. So if I have, like, for example, I'm going to just draw a random four-sided figure. Let's say I don't know the measurement of that angle, but I do know that this is 52 degrees. I do know that this is 98 degrees, and this is 137 degrees. Well, since we figured that all the angles need to add up to 360, I'm going to go ahead and use what I understand about algebra and say, okay, 360 needs to equal the sum of all of these angles. So x I don't know. Remember, sum means to add together. So here's my equation. And hopefully by this, all of you are like saying, oh, I know this. This looks familiar. Let's go ahead and combine our like terms, or at least our coefficients. I'm going to combine those three, and when I add together 52 plus 98 plus 137, I end up getting 287. I still have my x, and I still have 360 on this side. So how would you solve that equation then? I'm going to go ahead and subtract 287. Subtract 287. This cancels out. This turns out to be 73. And so our missing angle is going to be 73 degrees. Okay, we'll practice a lot more of these problems in class, so make sure you come with your notes ready.